Guys, I uploaded homework one, so did you guys check it out? Okay. So we have our first quiz next week, right? On Tuesday. So the quiz is gonna be something like this. It's gonna be on Canvas. It's gonna open the whole day, like let's say from the 24 hours, and at the end of the day at 11:59, it's gonna close. So you need to take the quiz before it's going to close, right? So I believe it's gonna be 30 minutes unless you have extra time. It's gonna be on the linear motion. There's no curvilinear motion, so you need to focus very well, and you need to understand graphs. Like sometimes I can give you the motion in terms of the text, or I can give you like a graph like this and tell you this is, for example, the speed over time. All right? So you need to understand how to use this graph to come up with the function of the speed. Will you guys be able to, if I give you a line, you find v as a function of t? You can develop the equation of the line, right? You can develop the equation of the line from the slope and maybe 1 point on this line or 2 points on this line. So you have to use your background in geometry so that you come up with the equation of the velocity as a function of time. Okay? All right. So today we are going to continue on the curvilinear motion, which is not going to be part of the quiz. You guys remember last time, we always have last time we talked about that maybe our body is moving on a curve. Like let's say you are going to describe this curve on a Cartesian coordinate system, and the curve is going to be something, for example, like this, and our body is somewhere at position R. So we describe the position of our body with a vector r, so that's our first thing that we have. I'm reviewing what we had last time. And then the velocity is always tangent to the curve of motion. So the velocity is always going to be something like this, v. So if you want to get the v vector, what should I do? It is the time rate of the change of the position. Okay? If I want to get the acceleration, it is the time rate of the change of the velocity. You can write it in a different way. This can be r dot, and this can be v dot or r double dot. So that's what we had last time. So if we are talking about Cartesian coordinate systems, so every component of the motion can have a component in the x and a component in the y direction. So you can have rx and ry. Same thing, the velocity can be component in the x, dx, and dy. And if your acceleration is that way, so the acceleration can have component in the x, ax, and component in the y, ay. All right? Does anybody have any problem? That's what we did last time. So let's solve a quick example on this. Example, let's say that we have a balloon, and this balloon is moving on a curve, like, and this curve can be described on a Cartesian coordinate system. Let's actually, it says, at any instant, the horizontal position of the weather balloon in the shown figure is defined by x equal at, where t is a second if the equation of the path is y equal x squared over 10. So it's saying that there's a balloon whizzer, and this balloon whizzer is moving on a parabolic path, something like this, and let's say our balloon whizzer is something like this here. And the equation of this path, y equal x squared over 10. So we have the first equation, y equal x squared over 10. And x can be described as a function of time, a t, and the units are in feet. So that's all the givens that you have. You have a balloon, this balloon is moving on a curve. You're not a straight line. And I give you the equation of the curve, and I give you x as a function of the time. So I'm asking you, determine the magnitude and the direction of the velocity and acceleration. So I'm asking for the v as a magnitude and direction. Same thing, the acceleration at time t equal 2 seconds. All right, let's solve this problem. Well, to solve the velocity, I need to have both components, the x direction and the y direction. The thing is, I only have the x component as a function of time. How can I get the y component as a function of time? Exactly, I already have y as a function of x, so I can substitute x here, so you can get that y equal to 8t all squared over 10. So it's gonna give you 6.4 t squared. So I found y as a function in time. Why did I do this? So I can differentiate y with respect to the time. If I differentiate y with respect to time, what I'm gonna get? V and y, right? So right now I have x as function of time, 8t, and I have y as function in time. So I can get dy, which is gonna be dy dt. So can you guys differentiate dy with respect to t? I want to differentiate this function with respect to the time. It's going to be 2 multiplied by 6.4 is going to give you 12.8 t. If I want to get vx, it's going to be dx dt. So I want to differentiate x with respect to t. It's going to give me what? 8, right? So I found the velocity in the y direction and the x direction. So actually, the velocity vector is 8 in the I hat direction plus 12.8 t in the g hat direction. I found the first thing. How about the acceleration? If you want to find the acceleration, ay is going to be equal to dvy dt. I differentiate one more time with respect to the time. So this is going to be 12.8. If I want to find ax, so it's going to be dvx dt. How about the differentiation of dx with respect to the time? It's going to give us 0 because 8 is constant. So the acceleration vector is x is first, or y. It's going to be 0 in the I hat direction plus 12.8 in the j hat direction. I'm almost done, but it says that it wants the magnitude and the direction of the acceleration. Right now I give it as a vector, so I'm almost done with the solution. And this is at time t equal 2 seconds. So at time t equal 2 seconds, v is going to be equal to 8 in the I hat direction plus 12.8 multiplied by 2 is going to give you 25.6 in the j hat direction. And the acceleration is going to be the same, 0 because it doesn't depend on the time, plus 12.8 in the j hat direction. I'm not done yet. I'm just to give the velocity and acceleration as a vectors. So if I want to find the magnitude, can you guys tell me how can I get the magnitude of this vector? If I want to find the magnitude of v, the square root, exactly. Excellent. 8 squared plus 25.6 squared. And this is going to be 26.82 feet per second. How about the magnitude of the acceleration? The magnitude of 0 squared plus 12.8 squared is going to be 12.8 feet per second squared. So right now I got the magnitude, but I didn't get the direction. Can you guys tell me how can I get the direction? The direction means it wants the theta of the motion. So let's say the velocity v has 8 in the x direction and 25.6 in the y direction. 8 and 25.6. That means that is the direction of the velocity v. And this is the angle theta. Can you guys tell me how can I get theta? It's the tan inverse of 25.6 over 8, right? If I got the tan of 25.6 over 8, and then got the inverse, I'm gonna get the tan. It's the same thing like saying that tan theta is equal to the opposite over 8. So, and then you take inverse for both sides, and then this angle is gonna be 72.64 degrees. How about the acceleration? Can you guys tell me what is the direction of the acceleration? It's very easy. It has 0 in the x direction and 12.8 in the y direction. That means it's only going up at 90 degrees. So it's only going up. So that is the acceleration vector at theta equal 90 degrees. And you can do the same thing. You can say that theta is going to be tan inverse of 12.8 over 0. So this is going to give you that theta is equal to 90 degrees if you do the angle calculation. Right? Does anybody have any question? Let's see what did I do. And the equation is giving you y as a function of x and x as a function of t. So what I'm interested in so that I can get the position, I'm interested in all the x and y to be as a function of t, because to get velocity and acceleration, I'm going to differentiate with respect to t, not with respect to x. So I have to convert y from being function in x to be function in time the same way that x is. So I take x, substitute it in this equation, and I got y as a function of t. So right now you have x and y as a function of t. Once you have them as a function of t, you can differentiate once to get velocity, differentiate second to get acceleration. And then I got these two functions, and then at one step, t equal 2 seconds, substitute with t in this equation, I was able to get the velocity and the acceleration. Does anybody have any questions, any concerns? All right.
It's not a big deal, but shouldn't it be 0 over 12.8?
It should be y over x, not x over y, and this is y. So x is 0, like same way that it is here. X is 8, so the tan is the opposite over the adjacent. So it's going to be this over this, y over x. Same thing, here's the y and here's the x. It's 1.8 over 0. And you will be like, oh, but 12.8 over 0 is what? Infinite, right? So if you put it in calculator like this, it's going to give you 90 degrees. Okay. All right, so maybe we solve, I have another 2 examples. I'm going to maybe solve another one to confirm the concept in your head. By the way, there's another way that I can solve this problem. That's why I'm looking at it. Like, let's say somebody right away, he went to the problem and said, okay, I have y, that's really, really easy problem. It gives me x and y right away. And x and y, that means the position. I differentiated them with respect to the time right away without make this as a function of time. It's gonna be a little bit difficult and need somebody who's really good at math, especially differentiation. You can differentiate y equal to x squared over 10 with respect to the time. Like you can say dy dt, but do you know how to do it? Does anybody know how to differentiate this function with a variable other than the main variable of the function? So it's going to be the same thing like differentiating with the same variable. So you are going to say this is equal to 2x over 10, but at the end you have to put dx dt. If I'm differentiating this function with respect to x, dy dx, this is going to be 2x over 10. dx over dx, which is 1. So that's why we can. This is different than this. And at the end, you need to find what is the value of dx dt. The value of dx dt is equal to 8, because this is 8t. So you need to take this out and put 8. So it's going to give you the same answer. So that's a different way to do it. If this is difficult, do it the same way that I have done. Okay, let's solve another example. Right, so it says for a short time the path of a plane is described by y equal to 0.001 x squared. So it says that you are in the airport and there is a plane want to take off. And let's say that this is x-axis and this is y-axis. And this plane is going to take off on this curve. This curve can be described y equal 0.001 x squared. And let's say that your plane something like this, and it's going to take off that way. If the plane is rising with a constant upward velocity, that means the velocity in the y direction, and it's constant. So Vy, that's how you translate the problem into variables. So constant upward velocity, so Vy is equal to 10 meter per second. All right? Determine the magnitude of the velocity and acceleration of the plane when it reaches y equal 100 meter. So at y equal 100 meter, it asks you what is the velocity of the plane, v, and what is the acceleration of the plane, let's say. So find v and a at y equal 100 meter. Okay, let's solve this. Well, the same thing. Y is a function in x squared, so it's not going to help me with finding velocity and acceleration because I need y as a function of time. Okay? So it says constant upward velocity. It didn't say anything about the velocity in the x direction. But let's see how we are going to get the velocity in the x direction. So this is the plan. First, I need to get Vy. From Vy, I need to get y. What is the position? Is it changing with time? So do you guys remember we have to, for the position, I have to differentiate to get velocity, differentiate to get acceleration. If I want to get from the velocity, I want to get the position. What should I do? I integrate, right? So what I'm going to do, I'm going to use the Vy and integrate it. Like I know that Vy is equal to dy dt. So if you guys remember from first principle, dy, and here's Vy dt, I can integrate them from y node to y, and this is going to be from t node to t. So this is going to be y minus y node, and I can integrate 10 dt, it's constant, so it's going to be equal to 10t, and since t node is 0, and I'm going to t, and y node is 0 because it's starting from rest, so y is equal to 10t. You see what did I do? From constant velocity, I was able to get the position as a function of time. And that makes sense. If the position, if 10, and it's a constant, and it's not varying with time, if you want to get, let's say your velocity is 10 miles per hour. So after 1 hour, how many miles are going to cover? It's 10 by 1. 10 by 1. So that's the position, right? Okay, so we have y as a function of t. Can we get x as a function of t? I have y as a function of x. So x is going to be equal to, can you guys tell me what it is? I can multiply by 1,000 both sides. So it's going to be equal to 1,000 y. And then I'm going to take the square root of all this. So this actually, yeah, that's right. Okay, so that's x root 1,000 over y, right? But that's not what I want. I want x as a function of time, right? So I have already y is equal to 10t. So I can substitute in this equation. So this is gonna be 10,000 t, right? So what I did, I put 10t inside this function. If I wanna get the square root of this, it's gonna be 100 root t. So right now, I have x is equal to 100 root t, and I have y is equal to 10t. We got to the same position that I have y as a function of t and x as a function of t. So I can get the velocity and acceleration and everything by starting the derivatives. Well, I can see that the derivative of y is easy. Do you guys remember the derivative of the roots? Like if I want to take the derivative d dt of root t. Okay, remember this. The derivative of any root is the derivative of what is inside the root. So the derivative of t is 1 over 2 the root itself. So if you take the derivative of root 10t squared. So what is the derivative of 10t squared? It's 2 multiplied by 10, 20. So you're going to have 20t, and then divide by 2 root 10t squared to the root. You can actually deal with this as like d dt, and you have t to the power half. Okay? The root t is t to the power half. We agree on all that? Okay. So if you want to take the derivative of t to the power root half, so what we do, we take the half and we put it here, and then you decrease this by 1 time. So this is going to be half minus 1, so it's going to be negative half, multiplied by the derivative of what is inside here, which is 1, because the derivative d dt of t is going to be 1. So this is going to be 1/2, and this is 1 over root 2. So this 1 over 2 root, sorry, not 2, it's t. All right, so we agree that the derivative of this is that. So if you want to get the derivative of dx dt to get vx, this is going to be 100 over 2 root t, because that is 1 over 2. So this is going to give you 100 over 2 root t. If you want to take the derivative 1 time, it's a little bit tricky. But we can write this as 100 over 2, and the root t is going to be t to the power negative half. Let's take the derivative one more time. Can you guys do it? Take the derivative of this variable. You all know the derivative of t squared, right? You always put the 2 down and put the t here, and it's 2 minus 1, so it gives you 1. So this is 2t, right? Same thing, we're going to do this one. d dt of t to the power negative half. So we're going to take negative half down here, and this is going to be t negative half minus 1. So it's going to be negative 3 over 2. So if you don't know this, you have to go back to the basics of differentiation. I already uploaded a math sheet that has all the basics of integration. Not the basics, it's like some rules. If you have x squared, how to differentiate it. If you have root, how to differentiate it. So maybe you go back and review how to do differentiation. So let's put this here. This is going to be 50. And if you differentiate this, as we agreed, it's going to be negative half multiplied by t to the power negative 3 over 2. So this is going to be negative 25 t to the power 3 over 2. Okay, so we are done with x, velocity, and x acceleration. So let's do y. Y equal to 10t. That's easy. You guys will tell me, how can I get Vy? Vy is equal to, it's given in the problem. It's equal to 10, constant, right? And if we differentiate this with respect to the t, it's going to give us 10. How about Ay? 0, because the differentiation of a constant is gonna get you 0. So right now I have v as a vector is gonna be equal to 50 over root t in the I hat direction, this one, and in the y direction I have 10 in the j hat direction. The acceleration is gonna be negative 25 t to the power negative 3 over 2 in the I hat direction plus 0 in the j hat direction. Right now, I got v and a as a vector, but I didn't get the values of them at y equal 100 meter. And that is a little bit tricky. Why? Because our functions are function in t, not y. So how can I convert y that is equal to 100 meter into a time? So the way that I do it is right now, like something like this. I have y as a function in t, so if y is equal to 10t and y is equal to 100 meter, and 100 meter I made it equal to 10t, so t is going to be equal to 10 seconds. How did I do that? I have y, the position y, as a function of time, and I've already given what is the value of y that I need to calculate the velocity and acceleration at. So if I have y, I can substitute here and get the time. So at time t equal 10 seconds, where y is going to be 100 meter, I can get what is the value of the velocity. So if I substitute here, so this is going to give me Vx of 15.81 in the j hat and the I hat direction, plus 10 in the j hat direction. And I can do the same thing here. I can substitute with 10 equal 10 seconds. So this is going to give me negative 0.791 in the I hat direction plus 0 in the j hat direction. That is the vectors, but if I want to get magnitude, the same thing that we did last time, we can do it now. We can get the magnitude by taking the square root of the x component and y component. So I have 15.81 squared plus 10 squared. And this is going to give me the magnitude of the velocity. I didn't continue. So it's going to be 18.7 meter per second. And the acceleration magnitude, that's easy one because I'm going to integrate negative 0.791 squared plus 0 squared, and it's going to give me 0.791 meter per second squared. Does anyone have any question?
To make sure, that equation means that when the plane reaches 100 meters, it takes 10 seconds to get to that point.
Exactly. So like to go all the way up 100 meter is gonna take the plane 10 seconds. Sorry. Oh yeah. We got it. Yeah, 10 seconds. Like this. And how did I get that? From the function y is equal to 10t. I already give you it. If it's 1,000 meter, so it's gonna be 100 seconds. If 10,000 meters, it's gonna be whatever. I divide 10,000 over 10. So you can't get the time because I already have this function. So that's the tricky part of this problem. It's the same like this one, but this one, I asked you directly to get it at t equal 2 seconds. But this one, I make it in y. But it's the same thing. If I have y as a function of t, I can substitute 100 meter equal 10 t, I can get t equal 10 seconds. And all what I did, I have x as a function of t, y as a function of t, start to differentiate to get velocity and acceleration. All right, so maybe you will think it's a complicated, but if you think about it, it's a step-by-step problem. You need to have the position equations as a function of time. Integrate them once you get the velocity as a function of time. Integrate them twice, you are going to get the acceleration as a function of time. And if I ask you to find not the general equation at a specific instant, you substitute with the time in each one of these equations. Okay, so we are done right now with the introduction of the curvilinear motion for Cartesian coordinate system. One of the main applications of the Cartesian coordinate system is the projectile motion. Okay, so what is projectile motion? Projectile motion is that you have a body and you are gonna throw this body. This body is gonna move on a curve. Like, let's say I'm gonna make like this. So take all the way that way until it came down, until it becomes here. So the best way to solve projectile motion is to use XY coordinate systems. Okay? So that's when I say in a problem that I have a projectile, it's mainly we are going to use XY coordinate system or Cartesian coordinate system. But let's analyze the motion of the projectile. What is like the speed? It depends on where's the body start. Like if the body started that way, so the speed has like this is the path is something like this. It's tangent to the speed. So the speed has an X component and Y component. Okay? Unless if the body just move X right away. And by the way, there's at some point, if I throw this body, it's gonna hit a specific point here where all the speed is Y. And then it's gonna convert. So it's going that way, that way, that way until it becomes a Vy, there is no X, sorry, Vx, there is no Y. So it doesn't go up, it becomes Vy, and then it goes down with Vx and Vy. That's one thing that you need to know about projectiles. The second thing about projectiles, what is the acceleration that affects this body? Is the gravity, right? So this is the only acceleration that we have here. This body, when it moves, there's no acceleration in the X direction. All the acceleration is going down. It's the gravity acceleration. So there is no acceleration in the X direction. All the acceleration is in the Y direction. That's why the body, it starts with Vx and Vy, and everything is going down because of the acceleration. All right, so let's put this into equations. Let's say that we have here X, Y coordinate system, and this how my body's gonna move. So the body started here with V node, and I always say that the velocity is always tangent to the path of motion. And this is the final velocity, V. So V node has a component, V node X and V node Y. And the final velocity has a component, Vx and Vy. And there is only one acceleration, A equal to G equal to, what is the gravitational acceleration? Do you guys know? 9.81 meter per second squared. All right, so do you guys remember when we wrote the equations of motion and we started to say this is variable acceleration and constant acceleration? Which equations are we going to use here? The variable acceleration or the constant acceleration? Constant. Why? Because the acceleration of the gravity is always constant during the motion. It doesn't change unless you went to a different planet. Okay? So as soon as the body is on Earth, that means that the acceleration is constant to 9.81 meter per second squared. Okay, so this is the equations that we have for constant acceleration, if you guys remember. S minus S node equal to V node T minus T node plus 1 over to A constant T minus T node all squared. And V minus V node is going to be equal to the A constant T minus T node, and V squared minus V node squared equal T A constant S minus S node. You guys check the sheet, the equation sheet that you have. You're going to find all these equations here, constant acceleration. So I'm not going to give you any inputs or any equations for the projectile motion because everything is here. Here is the constant acceleration. But the thing is, this is for linear motion. Right now we have our motion are in X and Y direction. So all what you're gonna do, you are gonna change S to one time to be X and one time to be Y. You are gonna change V to one time to be Vx and Vy. So the motion has a component in the X and component in the Y direction. So let's find out the horizontal component first. Alright, so as you guys see here, what we did when we were working is a body's moving on a curve. We divided the motion into an X component and Y component. That's the same thing that we are gonna do here. From what we learned right away, what information that we have about the horizontal motion, for the horizontal motion, we know that the acceleration AX is equal to 0. There is no acceleration in the X direction. And for the vertical, we know that the AY is equal to G. Right? 9.81. So that's what we know about these two motions. So if the acceleration for the horizontal motion is equal to 0, that means that all this term is 0, and all this term is 0, and all this term is 0. Okay? So that makes our problem very, very simple in the horizontal direction. So let's do this. This is going to be 0. Let's actually start with this. This is very simple. If I put acceleration here equal to 0, that means that Vx minus Vx node is equal to 0. So that means that the final X velocity is the same like the initial X velocity. So Vx is equal to Vx node. That is the first equation. This equation is going to lead to the same equation. If you put this is equal to 0, that means that the Vx squared is going to be equal to Vx node squared. Take the square root for both sides. It's going to lead to the same equation. So I don't have to do it again. Let's do this one. This one means that X minus X node is going to be equal to Vx node multiplied by T minus T node. So I can say that X is equal to X node, send the other side, plus Vx node multiplied by T minus T node. That is the first two equations of motion in the horizontal direction. Okay? And that's the most simple direction. That's why I always, when I solve a projectile motion, I start with the horizontal motion. And then start with the vertical motion. Why the vertical motion? AY is not 0, it has a number. So the three equations has numbers. So for the vertical one, maybe we can start with this one. So we can say that Vy is going to be equal to Vy node plus G Okay, here's the thing. The acceleration here, that's the thing that I did. I put here Ax is equal to 0. But look at this. I have x-axis is this way and y-axis this way. And the acceleration, it goes this way. So G needs to be negative G, not positive G, because it goes down. Unless your axis is down. If you made your axis is down, like if I made my xy axis like this, and I make that constant across the problem, and G is going down, so G is positive. Okay, so that's why I'm gonna make this negative G, so I send V node the other way, it becomes Vy node minus G, T minus T node. That's the first equation. Second equation, I can do this one, or I can do this one, whatever you would like. Maybe I would do this one and can say Y equal to Y node plus V node Y, T minus T node, and this one is going to be minus 2, so it's going to be negative 1 over 2, and G, I'm going to put G here, and T minus T node all squared. The last equation, which is this one, so it's going to be Vy Vy squared equal to Vy node squared minus 2G multiplied by Y minus Y node. That is the third equation. Okay, so I'm gonna leave this forward because we're gonna need all these equations for solving examples. Okay, so the thing is you need to memorize these equations or you'll be able to drive them. So you always have them in your head. So you don't have to prove them all the time. They are coming from what we learned, like the displacement, velocity, position, integration, and differentiation of them is gonna lead to these equations. And what we did, we made them in the x direction and the y direction. One of them substituted was acceleration 0, and one of them substituted was acceleration equal to negative g. So let's solve a problem and see how this is gonna look like. Say an example. So this example, say a sack slides off a ramp. So you have a ramp here. Let's say this is a ramp, and there's a sack here. It's gonna slide like this. And this sack is sliding. This is horizontal. With horizontal velocity, v equal to 12 meters per second. And definitely there's acceleration going down, which is the gravitational acceleration g. And from here to here is a distance that we don't know. It's called r. So this is the distance when the sack moves all the way on the ramp and then it slides and comes down here. So this is the distance r. And the height of the ramp from the ground is 6 meters. So it says a sack slides off the ramp with a horizontal velocity 12 meters per second. If the height of the ramp is 6 meters from the floor, determine the time needed for the sack to strike the floor. So the time needed for the sack to go all over this path to come here. And the range r where the sack begins to pile up, like here. This one. So let's find out. This is a pure projectile motion. Body's moving on a ramp, and the ramp is gonna push that body to move on a path and land on the ground at a distance r. So let's find out how we can solve this. The first thing that you think about, you need to divide the motion into x direction and y direction. Don't think about something else. Because if you think about the motion as xy, you will not be able to solve it. You have to divide it in x and y, and everything is given as x and y. Look, the velocity is given as x direction, and the height is given as a y direction, and it needs the r, which is an x direction. So you need to think x direction wise. And to do this, I have to start with my axes. You can put your axes wherever you want. You can put them here, you can put them whatever you want. So what I'm gonna do my x-axis here. This is x, and this is y. So anything below x is going to be negative, above x is going to be positive. Okay? All right. So what I'm going to do, I'm going to say number one, or let's say horizontal motion. So for horizontal motion, this is my equation. Vx minus Vx node is going to be equal to 0. By the way, this is Vx or Vx node? What is this? This is the initial velocity. The Vx is here, this is the final velocity, and this is the initial velocity. So I know that Vx node is equal to 12 meters per second. So Vx is going to be also equal to 12 meters per second. Okay? Because this is from the horizontal direction. So I got the final end. So let's do the second one. It says that the x equal to x node plus Vx node multiplied by t minus t node. That's the second equation. So x, that means the final distance in x direction, or the final position in the x direction. So the body start at x equal what? 0. And end up at x equal what? X, which is r, right? So I can say that r is going to be equal to 0 plus Vx node, which is 12, multiplied by t, which I don't know, and the body started at t equals 0, so minus 0. So that means that r is equal to 12t. Well, I didn't solve the problem, but at least I got an equation. I got r as a function of t. And by the way, this problem is asking about both r and t. What is the time that the sack needs to hit the ground, and what is the horizontal distance? So that is the first equation. Well, you might say maybe it wasn't smart to start with the x direction because it gave me one equation and two unknown. I need one equation and one unknown. You can start with the y direction. But for me, I would start more systematic. But if you are smart enough, I'm doing it systematic, I'm doing the horizontal direction and then the vertical direction. So you can like, oh, this one, I don't know, a lot of variables. So I'm gonna hold on the horizontal motion and start with the vertical motion. So you can do that. But what I did is still also right. So I can next do the vertical motion. So for the vertical motion, I have three equations. So let's be smart enough and pick the one that's going to be solved right away. So let's say y minus y node. So y minus y node, I already have. Y node is 0. What is the final y? Minus 6, because I go down, right? So 0, y node is 0, and this is minus 6. How about v node y? Do I have v node y? I don't have any velocity in the y direction. Let's start with a horizontal velocity vx. So all this term is going to be 0. Okay? How about g? I know g. It's 9.82. What I don't know is the time. So this is going to be function only in time. So I can't get the time right away by solving this equation because I know y, I know v node y, and I know g. So let's do this. So I can say that y equal y node plus Vy node t minus t node minus 1 over 2 multiplied by g t minus t node squared. That's the equation. So y, we agreed it's going to be negative 6, and y node is 0. Vy node is 0 because the body, when it started with just horizontal velocity. Once it hit the curve, it starts accumulating y velocity. Okay, 0, and this is going to be 0, this term, minus 1 over 2 multiplied by 9.81 multiplied by t squared, because t node is also equal to 0. It starts at t equal to 0. So right now I can find what is the value of t. So when you solve this equation, you are going to find t squared is equal 1.22, so the t is going to be equal 1.11 seconds. All right, I found t. What is next? I substitute in this equation to find r. So r is equal to 12 multiplied by 1.11. So this is going to give you 13.27 meters. So r is 13.27 meters. So I solved the problem. By the way, in just the three equations, just understand the problem. Now I understand that there's a body, it's going to start with a horizontal velocity, and it's going to take the curve until it hits the ground under acceleration g. So I divided the motion into x component and y component. The x component, I put the x equations. Y component, I picked the easiest equation that can make me solve the problem. You will tell me, what if I used other equation? You are gonna get there, but you are gonna take a long time. How? Let's say that the thing is, with this equation, Vy at the final position, I don't know it. Okay, so this is gonna take me some time. I know that Vy node is 0, so you are gonna end up with an equation Vy as a function of t. And here, this one, it can solve it. Like, let's say Vy node, it's the same thing. Okay, yeah, solving this equation, you are gonna get Vy. Vy node is equal to 0, g is equal to 9.81, y is equal to -6. This is 0, you are gonna end up with Vy. You take Vy, substitute in this equation, Vy, and this is 0, and this 9.81, and then you have this t, so you have to solve two equations to get t. What I did here, just one equation gave me the time. So you need to be smart to pick the equation that takes less time. Okay, so let's solve another problem. Does anybody have any question? Is it difficult? I know dynamics is difficult, but I mean, is the problem is difficult? A little bit.
It's just the equation.
Is it?
Doing
Yeah. Well, that's dynamics. It has a lot of math, so you have to get used to it, and you have to focus on numbers, because if you put like the same way that I did it here, this negative, if I put it positive, is gonna ruin the whole problem. You are gonna get a completely different answer. And guess what? When I took this class, and I don't know, 2008, like I don't know, 15 years or 17 years ago, this class, the exam was, you get the grade based on the final answer. It's just MCQ problem, and you solve, and you either find the number that you solved in the multiple answers. So you choose A, B, C, and D, or not there. So if you got all your answers wrong, so not at all, like not all of the above answers. And if you pick one number, you said, okay, I'm smart enough, I'm gonna solve the whole thing without solving any problem. Every one question that you solve it wrong, you get -1, not 0. So if you solve it one correct, so the one wrong is gonna slash the one correct, so you get -1. So, but this exam is gonna be not that way. Like, it's gonna be, you are gonna get partial credit on your effort. So let's say that you solved the questions and you just messed up with like positive or negative or something. Maybe you will lose 1 or 2 points, but I'm gonna give you some points based on your effort. Okay. All right. So let's solve one last projectile motion problem. All right, so this problem says that the track for a racing event was designed so that the riders jump off a slope at 30 degrees from a height 1 meter. During a race, it was observed that the riders shown in the figure remained in mid-air for 1.5 seconds. So the rider, when jumped, that's a projectile motion. Well, it wasn't projectile as when he was moving here, it was forced movement. So it was forced movement until he get out of this track and start jumping in the air. Right now it start becoming a projectile motion. It jumped with a specific velocity that we don't know, v, at an angle 30 degree. Like let's say that we said this is the x-axis and this is the y-axis. And then it stayed in the air, remained in the air for 1.5 seconds. You have to use all the information given in the problem. So the time t is equal 1.5 seconds. So let's assume that starts at t naught is equal to 0. T here was 1.5 seconds. And cut horizontal distance r and was in the air on this track until like this is how the y position looked like. It was here, 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 and then goes all the way up and then drop down like this. Okay, remain in the air for 1.5 seconds, determine the speed at which he was traveling off the ramp. You want the speed that was traveling off the ramp, the speed here, E. The horizontal distance he travels before striking the ground, R. And the maximum height he attains. So we need to get V, we need to get R, we need to get H, small h, this h. All right, so let's use what we have. Neglect the size of the bike and the rider. Neglect the size of the bike and the rider, that means that we are gonna deal with them as a one single body, okay? All right, so let's see how we can solve this problem. All right, we are gonna do the same thing. We are gonna use the same equations over there, and the x and in the y direction. But maybe in that time, let's use the vertical motion. You can use the horizontal motion first. Like you can substitute in these equations first. But what I'm gonna do, I'm gonna substitute in these equations first because it's gonna be much easier. Why? Okay, let's find out. I know y initial is equal to 0, and I know what is the value of final y, right? Here the y is what? 0. Here's the y is -1. So I know the verse 2. The second one, v naught y, I don't know it. That's the velocity. That's what he's asking for. I know the time, t minus t naught. And I know the g, 9.81. I know t minus t naught. So I know everything except v naught y. So I can, the best way is to make the equations are one unknown. In two unknowns, you will not be able to solve them. That's what I did here. It's gonna be only one equation and one unknown. So let's put vertical motion. You guys tell me the equation because I can't see it. I believe it's y for y naught plus v naught y. Are you guys gonna tell me? Okay, t minus t naught minus 1 over 2 g t minus t naught squared. Okay, so y we said is gonna be -1, 0, v naught y, and t we said it's gonna be 1.5 seconds minus 0 minus 1 over 2, 9.81, 1.5 minus 0 all squared. Solve this equation, you will find out that v naught y, okay, we did it in a different way, but it's gonna give us the same thing. So you will find that v naught y is something. Let's see if I got it, v naught y here. Okay, so you will find the value of v naught y. If you have a calculator, you can calculate. What I did here, I mean like solving it here, I said that v is gonna have a component in the x direction and component in the y direction. So I'm gonna have vx node and vy node. Can you guys tell me what is the value of vx node? It's gonna be v cosine 30. And vy node? V sine 30. So what I did here, I moved vy node and I put v sine 30. And then at the end, I got the value of v, and that's what I got here, which is v node. This is v node sine 30. And I got v node of 13.38 meter per second. And that's what I'm interested in. V at the speed at which he was traveling off the ramp. V node. I got the first one. So you either put it V node sine 30 or you put it V node y, and once you find V node y, you say that this is equal to V node sine 30 and divide by sine 30.
Could you say that one more time?
Okay, so I can keep it that way. So the way that I solve it here in the normal answer, I mean like in my notes, rather than putting V node y, I put it V node sine 30, okay? But let's say that I kept it V node y. At the end, let's say that we found out that V node y is 15, okay? So V node y is equal to V node sine 30, right? So V node is gonna be equal to 15 over sine 30, and then you get it. Okay, so it's gonna be the same thing. All right, so I got the first one. Let's find R. Since R is X, so right now I believe, like here, which equation? Yeah, since R is X, so I have to substitute in this equation, right? Because you will not find an X position from Y equation. You will find X position from X equation. So I'm gonna take the X equation here and solve it. So I'm gonna have this equation X minus X node, or X equal to X node, Vx node, T minus T node. What do I know about this equation? What variables do I know? What is the value of X at the end of the motion? Is R. The start is 0, right? But the end is R. Like it starts at X equals 0, at end at R. So this is R, what I'm looking for. X node is 0, plus Vx node. How we can get Vx node? Cosine, right? We already knew V node, right? Here. So Vx node is gonna be equal to V node cosine 30. I got V node 13.38 cosine 30, and this is gonna give us Vx node of, I didn't calculate it, so maybe you will calculate it and you plug it here. So what I did here, I put 13.38 cosine 30 multiplied by 1.5 minus 0, and then I got R. So R is gonna be equal to 17.38 meter. Does anybody have any problem with this? Okay. So right now I got R. So what we did exactly, we substituted into equations, y and x. Y, I got the velocity, and then I used the velocity to get this velocity, and then I got the x position. All right, the final thing, I'm looking for the maximum height that this wiper reached. You guys remember when I threw the bin? It got to a maximum height. Do you remember what is the boundary condition, or what is the condition at the maximum height? The bin was like this. It has velocity Vx and Vy. What is happening to the velocity in x and y while it's going up? So Vx, the angle is something like this. The thing is, Vx is keep getting, like Vy is keep getting smaller, smaller, smaller until it reaches to 0, and then become negative, negative until it drop down. So what happened here to the velocity?
Vy is 0.
All the velocity are in x direction. So Vy, so at h, at the maximum height, the velocity Vy is equal to 0, because all the velocity is going to be in the x direction, right? So if you know that Vy is equal to 0, so I can substitute here and get the time where this is equal to 0. So, or actually we can do it in a better way. Where's the other equation? Yeah, this one. This one is going to get you the same thing, but I mean this one is much easier. Why? Because I'm looking for y. I'm looking for this y. So if I know the velocity, I can get the value of y. So can you guys tell me the equation up there? Vy squared minus Vy node, or equal to Vy node squared minus 2G
2G y minus y node.
y minus y node. All right, so what I know about this one, I know that Vy at the position that I'm looking at is equal to 0, and I know Vy node, so I know this is equal to 0, and this is gonna be equal to V node sine 30, so this is gonna be 3.38 sine 30 square minus 2 multiplied by 9.81, and my y is gonna be equal to, by the way, the y that we are gonna find out is not h. The y is gonna be this height, right? Because that's the x, it's gonna be measured from here. So, y minus y node, which is 0. So once you solve this, you will find that y is equal to 2.28. Did I solve the problem? No, what is missing? I need to find h, not y. H is this total height. So h is gonna be equal to y plus this height from the ground, 1 meter. Y plus 1, which is 2.28 plus 1 is gonna be 3.28 meter. Questions? You guys get that? All right, so what happened here is we have this equation, Vy squared, Vy node squared 2G, y minus y node. Y is measured from x-axis, not measured from where you hit. And this is my x-axis. So every y is gonna be measured that way. Do you remember when we calculated y here? It was -1. Why? Because it's measured from x-axis, which at top. Right now, my point is above x-axis, so it's measured from the x-axis, which is 2.28. But I'm not interested from the point from h-axis. I'm interested for h, which he named it as, just to make sure, where's the, oh my god, there's lots of stuff here. The maximum height he attains, and that's the maximum height he attains, h, and he named it as h. So I need to put 2.28 plus 1 is gonna give me 3.28. By the way, if you try to use other equations other than this one, it's gonna lead you to the same way, but you have to use two of them. First, you have to use this one, and then you are gonna find a variable, and then substitute in this one, so that you can find the value of y. Okay? But one equation give me what I want, so why do I do that? I do it the hard way. Okay? Does anybody have any questions so far? So right now we are done with the projectile motion. I added some more examples. I solved them either on the projectile motion or the curvilinear motion. Next time we are going to have different type of motion. We are still on curvilinear, but using different coordinate system. It's called tangent and moment. Okay? All right. See you guys next week.
Thanks, man.
Yeah, that's
It's good, bro. What's up?
Is that available? Is that
Yeah,
available?
like how it's increasing or decreasing, or the position it goes decreasing and then decreasing again. So just describing what is decreasing and what's increasing.
Go to for part C or
exactly what is the question saying? So can you tell it? Can you?
It's asking how far the car travels in meters, and you basically puts the function in terms of acceleration. So it was, what I did was integrate the velocity function that I got in the first part.
Okay, so I give you this, the velocity as function of t.
No, the acceleration.
Okay.
And then I got the velocity as a function of t.
By by integrating in the acceleration, so you got it that way.
Yes.
And you integrate one more time to get the position.
Yeah, but then when I do it, I get this 75, and the answer's only 2. I was like,
So maybe you messed up with something.
well, okay, so this is, I guess, this might be part of it. When I integrated the first time,
So let's look at the equation. Tell me the alright. Tell me the acceleration.
it's A equals 6.71 t to the 0.5 power.
Okay. So when did I give you boundary conditions?
How long does it take in seconds for the car to accelerate from 0 to 60 miles an hour? And then the acceleration is in meters per second.
And final V is how much? 60 miles per hour. I believe maybe you have units problem. Did you convert the 60? All of them
So when I did it the first time, I got time and.
Okay, I have the model answer in my office. Maybe we can jump there if you have a few minutes, and then I can check the numbers with you. The other class is gonna come right now. Yeah, it's from the
Change their weekly agenda.
Right, see you in my office.
Yeah, it's 30.
36 to 6.